Taking a look at example 2, we want to describe how the given function, in this case g of x equal to 2 over x plus 3, is a transformation of our function f of x equal to 1 over x, a reciprocal function. First thing to do here is let's see how is our function stretched or shrunk vertically or horizontally. So if we notice we multiplied 1 over x times the value of 2 here. So we can pull that 2 out. And what happens when we multiply our entire function by 2? If you remember back to an earlier section, when we multiply the function times a value such as 2, we have a vertical stretch by a factor of 2. Then let's look and see how is our function shifted left or right or up or down. Well, we have x plus 3, so our function would 1 over x would be shifted to the left 3. So we multiplied f by 2 and plugged in x plus 3 to get our shift of original function reciprocal. Now let's find our horizontal and vertical asymptotes. For vertical asymptotes, we're looking for what value of x would give the domain equal to 0. It would be x equal to minus 3. Sorry about the handwriting, it should be minus 3 there. So our vertical asymptote is x equal to minus 3. And we notice that the denominator has a higher degree polynomial than the numerator, so we would have a horizontal asymptote at y equal to 0. Now we want to look at in behavior of our function. So the limit as x approaches, let's say, plus and minus infinity. Remember, it's going to be the same. It's always going to be our horizontal asymptote. So the limit as x approaches plus or minus infinity, f of x approaches 0. That's in behavior. Now let's study what our function does as it approaches a negative 3. So again, we'll have to do this from the left and the right. So the limit as x approaches negative 3. From the left we write what again? Minus sign. So if we plug in, say, a negative 4, we would get negative values out of our function. So our function must be approaching negative infinity. And that's from the left. Then for the right, and it could be either positive or negative infinity. Let's see for sure. Limit as x approaches a negative 3. From the right we would write plus sign. F of x equals, if you were to plug in values such as a negative 2.5, negative 2.6, getting closer and closer to negative 3. We're getting positive values out of our function. So our function approaches a positive infinity. Okay, so I've zoomed into the graph so I can easily graph this. Remember, our function is 2 over x plus 3. So we have a horizontal asymptote at y equal to 0. So our function approaches negative infinity. Sorry, as x approaches negative infinity, our function approaches 0. And as x approaches positive infinity, our function approaches 0. Then we had a vertical asymptote at x equals a negative 3. So I'm going to draw that in a different color. And remember, the function as it approaches negative 3 from the left approaches negative infinity, so it's going to go down like that, and positive infinity, so it will go up like that. And that would be sufficient enough graph. I just want to make sure you have the in behavior and the behavior of the function as it approaches its vertical asymptote. Now let's look at part B. So remember, we're trying to find out how is h sub x a transformation of the function 1 over x. And at first look, it may look so. Are there any ideas how we could simplify this? It's going to take a little bit of polynomial long division. So we want to divide 3x minus 7 by x minus 2. So x will go into 3x 3 times. So we get 3x minus 6. Changing our signs simplifies to negative 1. So now we can rewrite our original function as 3 minus 1 divided by x minus 2. So 3 was our result, and negative 1 would be our remainder divided by x minus 2. Now, is it a little clearer how our function 1 over x is shifted? Well, it's stretched by a factor of negative 1. And shifted to the right 2. And up how many spaces? Plus 3. Okay, so we found how our function is transformed. Now let's find our asymptotes. So we have x equal to what for a vertical asymptote? 2. Then notice we have the same degree polynomial in the numerator and the denominator. So we will write 3x over x to help us find out the horizontal asymptote, which would simplify to 3. So we have a horizontal asymptote at y equal to 3. Okay, so let's clear that. Now let's study in behavior. So remember, in behavior is going to be the same thing as our horizontal asymptote. So the limit as x approaches both a positive infinity and a negative infinity, our function tends toward 3. So that's the in behavior. Now let's study our limit at x equal to 2. So limit as x approaches 2, from the right we write a plus sign. And f of x, so we just want to plug in values larger than 2. And if you do that, you'll notice that it tends toward negative values. And I wrote f of x, but really I should have wrote h of x that equals a negative infinity. Calling that, then studying the limit as x approaches 2 from the left, writing our 2 and our minus sign, h of x approaches positive infinity. Zooming in to graph our function, we want to graph the horizontal asymptote. Remember y equals 3. And our vertical asymptote at x equal to 2. Then, since our function is approaching a positive infinity from the left, then we know it must be approaching y equals to 3 above it. So it's going to go this way, then up this way. And really I drew my y-intercept above where it actually would be. If you plugged in 0 there, you would get 7/2. Then from the right, I'm reaching a negative infinity, so it must go to y equals 3 below y equals 3. So our graph will look like that.